Okay. Hi, everyone. It looks like we are officially live. It's so great to see you all joining this live stream and welcome in. It is 10:59 a.m. over here in Santa Cruz, California. So we are getting started just about a minute early to give folks the opportunity to settle into this live stream and get excited for a wonderful program we have lined up for you all. And so as we're waiting to get started, you can go ahead and introduce yourselves in the YouTube live chat. We love to see where our supporters are watching from, where they're tuning in from, and we even may give you a shout out during today's program too. So go ahead and say hi and introduce yourself. All right. Hi, everyone. If you're just joining us, we will get started in just about a minute or so. We're giving folks the opportunity to get settled in and get ready for this wonderful Labside chat with us. Awesome. Awesome. So this looks great. So it has hit 11 o'clock a.m. over here in Santa Cruz, and let's go ahead and officially get started. There really is no time to waste because we have a great program lined up for today. So hello, everyone, and welcome to the very first Labside Chat of the new year with the Seymour Marine Discovery Center. My name is Jen, and thank you so much for joining us today. If you have watched a Labside Chat before, welcome back. We're so happy that you're here. But if this is the first time you are joining us for a Labside Chat, today's program is an opportunity to have a Q&A conversation with a scientist from UC Santa Cruz to discuss how scientific research plays a role in the conservation of the world's oceans. And today is really, really special because we have an amazing guest lined up. We have the opportunity to talk with and ask questions to Dr. Adina Paytan. And Dr. Adina Paytan is a research professor of chemical oceanography within the Institute of Marine Sciences at UC Santa Cruz. And we will be talking all about the interactions between people and the ocean with a real focus on present and past climate and pollution. So Adina, thank you so much for being here today.
Thank you, Jen, for having me, and thank you for all of you who took the time to be here and ask questions and learn more about the ocean and how people impact the ocean.
Yeah, definitely. And so we have a couple of viewers. Thomas is tuning all the way in from Santa Fe, New Mexico. So it looks like our folks are really interested about the ocean and really excited for this conversation. And Adina, I have so many questions lined up for you that were actually submitted in advance from community members. So I really hope you're ready, and I hope we get to all of them because they're really, really great questions. But I also want to say too, for everyone watching at home, if you have a question for Adina at any point during today's conversation, please do not hesitate to go ahead and put that in the live chat as well, and we'll be able to answer those too. So Adina, are you ready?
I certainly am.
Good, it's like a rapid fire question round. So one of the questions that kept coming up that were pre-submitted by community members was, what type of questions are you trying to answer and address in your research?
That's a very, very good question because this is really a dynamic thing. What motivates me is what happens in the world and how can I, as a scientist, address these issues and answer them? And mostly am working or focused on what's the status of the ocean, how people change the natural processes in the ocean, and what are some of the solutions that we can or cannot implement to slow the impacts or, come up with ideas of reducing the negative effects that either are natural because of climate change or are more local and induced by people, although a lot of the climate change obviously is man-made because of fossil fuel burning as well. So in my research, I kind of try to ask and answer questions like, what are the sources of contaminants and pollutions to our coastal systems? How do ecosystems and organisms how are they affected by our activities and by natural changes in the environment? Generally speaking, how does the world work?
Yeah, well, it sounds like you have some really big questions on your hands. But and so when you're doing your research, are you mostly focusing on marine ecosystems, freshwater ecosystems, or terrestrial or land-based ecosystems?
Most of my work is in the coastal zone, which is mostly marine ecosystems, but because it's close to land, it includes estuaries like Elkhorn Slough, for example, or the San Francisco Bay. And that's where a lot of the interaction between land and the ocean occurs. And that's where people are using the ocean most. So that's where a lot of the action is. But I have worked before both on lakes and land ecosystems as well as the blue ocean offshore.
Yeah, definitely. And so, have you always been interested in this interaction between people and the coastal zone? Is that something you always knew you wanted to kind of dedicate your life to?
That's funny because actually what drove me or the way, my path to deciding to become an oceanographer was very convoluted, mostly because I never knew what I wanted to do. So, I mean, I studied biology and geology as an undergrad. Then I did some chemical oceanography and studied past oceans. And as I evolved with my career, I realized that it's really important to include the human aspect and to think about what we can or cannot do and how we change these natural processes. So it's not something that I can say I was like thinking about from the get-go, but definitely the more I understood how much impact we have, the more focused I was on these issues.
Yeah, definitely. And you also mentioned oceanography, and I am really curious about that because what exactly is oceanography? I was doing some poking around on your website, and there's also a term on there which really stood out to me, and it was paleoceanography. And so I was hoping that you could describe what is it, because I have no idea, and how is it incorporated into your work?
Sure. So I'll start with kind of explaining what is oceanography. Oceanography is the studies of the ocean and the interactions between the ocean and other spheres, the ocean and the atmosphere, the ocean and land, the ocean and the water in the ocean and the bottom of the ocean. And it includes aspects of chemistry. So like what are the elements and chemicals in the ocean and how they move around, currents, which is physical oceanography, and the organisms that live in the ocean, which is biological oceanography. And of course, how the ocean basins change and the sediments accumulate within, which is marine geology or geological oceanography. So it's very, very interdisciplinary. Now take it another step and you go to paleoceanography. Paleo means old or past. And then we kind of become detectives and try to understand how the oceans functioned, operated in the geological past. And it could be something that was or occurred 100 years ago, which we don't know because we weren't there to measure, or 1,000 years ago, or millions and millions of years ago. So studying how the oceans operated, what were the processes, the circulation, the currents, the organisms that lived there in the ocean in the past is paleoceanography. And it's important that we study this because right now our perspective or our point of view is kind of temporally narrow because we've been measuring things around us as scientists only in the past couple hundred years. And the conditions on land were kind of, have not been broad enough or wide enough to help us understand, say, what will these, how will organisms respond, or ocean circulation respond to conditions that may be on our planet 100 years from now.
Mhm.
So going to past times where maybe the temperatures were higher, or the ocean had less oxygen, can tell us more about what to expect for the future.
Definitely. And when you're looking at the past and you're playing detective and piecing all of these parts together, what evidence are you looking at? Are you looking, are you looking at different, rocks in the ocean, ice cores? What evidence is there?
All of the above.
Okay.
So our evidence, or what we call archives, are our history book that we use to learn about the past. And because we can't really measure the temperature in the water of the ocean a million years ago, what we can do is look at proxies for temperature, or things that can give us clues about what that temperature was. And this could be things like ratios of elements in the shells of fossil organisms. Obviously, the deeper we go in time, the less accurate this is. So we have to kind of put the pieces together, maybe look at multiple proxies and see how they agree with each other. But these chemical clues can help us reconstruct the conditions in the past.
Yeah, definitely. And when you're looking at these chemical cues, how do you know that it could be evidence from the past? Like, what is there something within the chemical that gives you a hint to be like, oh, this is from 1,000 years ago, or this is from 1,000,000 years ago?
Well, first we have to kind of accurately as we can, put an age to that record that we're producing. And this we know from biological evolution. That's called biostratigraphy. We can date things with radioactive decay clocks. So we can use multiple different things to actually put an age to our record. And then we also use the present to learn about the past. So if we can look, for example, at shells of organisms that live in Alaska, coastal Alaska versus coastal Hawaii, we know the temperatures of the water there today are different. So we can calibrate our proxies based on observations in the present and based on lab experiments that we control and grow things at different temperatures or different oxygen levels, and then calibrate what we measure in the past and translate it.
Yeah, definitely. And so we got a really great question asking about looking at the evidence to learn more about the past. And so is there specific parts of the world that you can go to where there's lots and lots of evidence of past climate records or past ocean records?
Sure. And so that really depends on what time span of the past you're looking for. Obviously, we have ice cores, and ice cores are really amazing recorders of atmospheric gases, for example, and temperature. But these ice cores only give us information of the last about 500,000 years of Earth history. We have corals, and corals are amazing because you can take coral cores and the corals grow annual bands. So you can actually get annual resolution and get information that is, seasonal or annual based on these coral cores. But that again, you have these corals maybe for a couple million years. If you go further back in time, the corals become fossilized and they lose their integrity. As you go further back in time, the archives change and you end up working mostly with deep sea drilling cores. So you drill the bottom of the ocean and get a core of sediments. And these sediments accumulate layer after layer as the stuff sinks to the bottom. And then if you can date these sediments, you can then analyze them, find little tiny microfossils in them or other minerals that will tell you about the future.
Wow, that's incredible. So depending on what time scale you want to look at, you will look at different archives. And so
Exactly.
what is your lab and what is your research? Like what time scale do you mostly focus on? So what does your lab use as your archive?
So we work on multiple time scales for certain questions, like how do people impact coastal chemistry or coastal pollution? We're talking about a shorter time interval, and for that we mostly work with corals and coral records. But then when we're looking in deep time, I work mostly with the sediment cores that are retrieved by this international ocean drilling program.
Gotcha.
And mostly I don't go very, very, very deep time beyond about 100 million years ago. So even 100 million years ago is short in terms of the age of this planet.
Right, right. It's just always funny to hear, 100 million years ago, that's like a blink of an eye. So it's always funny to hear. So, Adina, we also got a really great question from someone that wants to know a little bit more about the connection between humans and coastal zones in the ocean, and specifically about human impacts to marine animals. And so if you can elaborate a little bit more about the research that you're doing now to really understand how humans are impacting marine organisms.
So one thing that I do that is directly relevant or related to that is look at how pollutants that come into the ocean through groundwater discharge affect the ocean. So I'm not sure that we all have an appreciation to that, but everything that goes into our water and then we flash on the toilet or the rain takes to the drain from our lawns or from our environment, all of this eventually ends up in the ocean. So every pollutant that we discard intentionally or unintentionally, including particles that are in the air that fall with the rain, ends up in the ocean. And with human activity, all of this stuff it may go that doesn't belong in the ocean. For example, the ibuprofen that we take, or estrogen, or caffeine, the coffee and the Coke that we drink. This all goes into the ocean. Now, these things don't belong there, and they may or may not have negative consequences on the environment and on organisms. For example, mercury or lead or other toxic metals, or something that has been very popular recently to talk about is plastic. So all these artificial plastic materials that we use, they decompose, they go into our water, they go into the ocean, particles are in the air, they fall into the ocean. And I'm sure you all seen these gory pictures of turtles stuck in plastic nets and dissecting fish and finding all sorts of plastic syringes inside them. So that's where I think it's very obvious and clear that we are impacting the ocean, including way offshore.
Mm-hmm. Yeah, it's definitely not a pretty sight to see those photos, but I'm so glad that UC Santa Cruz has folks like you to work on this problem, to really understand how humans and the ocean can exist and make sure that we're not negatively impacting this this ecosystem. And so a lot of folks at home that are watching are really curious as to what we can do to make sure that we're not impacting or negatively impacting this ecosystem. So do you have any advice from as a scientist as to what folks at home can do to help?
I think the main thing that people can do is educate themselves. if people are aware, I think nobody really wants to cause harm. There is no benefit to anyone if our ecosystems are damaged, because we can benefit less from damaged ecosystem, and we rely on these ecosystems, whether it's for our recreation, going diving in Hawaii and enjoying the beautiful corals, or our fisheries, or our beautiful blue oceans that are not affected by harmful algal blooms that can poison our dogs or whatever. So I think if we understand how and what our actions cause, with a little bit of change in our lifestyle, we might be able to contribute to reducing the impact. So first and foremost is awareness and education and understanding. And then everyone should or could decide to do what works for them. It could be as little as not using fertilizers on your garden, or if you use them, use certain fertilizers that are slow release and use them in a way that is more responsible. Um, you know, as a community, we can decide to treat our waters before we release them, or actually not release sewage treated waters to the ocean, but reuse that water, for example. We have the technology, it will be more expensive to recycle that water to drinking level. So we don't have to release fresh water into the ocean, for example. So there's a lot of things we can do, and just being aware of it and educating ourselves and educating at schools is a long ways.
Yeah, I love that. Just education and awareness is really the first step. And as you said, just small, tiny changes along the way can really make a huge impact, especially when everything is added up together. So thank you for sharing that. That's really great. So Adina, I have another question for you, and it's one of my all-time favorite questions to ask. What is your favorite part of the job, or what has been the most memorable part of your career?
I would say what attracts me to this work, there's two things. My curiosity, so kind of, finding or realizing that I can find something new that nobody else knew before. That's kind of very interesting and very fun, even if it's a little thing, the fact that, wow, I can do this and that and find something new and exciting that will be useful, that other people may want to learn, even if it's only my 20 colleagues, but still that's something that is exciting and helps motivate me. And the other thing, in addition to the discovery angle of science, I think the interaction with people, the education angle of being a professor, working with students and providing, the next generation of scientists with tools that they could continue informing the rest of the world.
Yeah. Oh, that's amazing. Oh, that's so great. So Adina, that is actually all of the time that we have today. And I am really sad about that because I feel like I could talk to you for the next 6 hours about your research and what you do. But unfortunately, we don't have that time. So do you have a place online or a website or social media where folks can go to learn more about you and your research?
Absolutely. My lab has a webpage, and I think if you just Google Paytan Lab UCSD, you will find it easily, or Jen, you can put that on the link. And there you can find more information about my lab members, our research, our outreach and education programs, and a lot of other fun things like pictures from Halloween that we dress up as the lab all every year and things like that. So I think, in addition, if anybody has other questions, you have the contact information on that webpage, and you can get in touch with my students, myself, or anybody else. and we'll be happy to answer more questions or talk to you all.
Awesome. And I know that your website is really a really great place to learn more about your research and really dive into some of the projects that you and your students and everybody in your lab is working on. So thank you so much for sharing that. I also just shared the link in the live chat within YouTube, so folks can go and click on that. I will also be sharing the link in the video description below after we wrap up this live stream here, so folks can easily access it as well. Adina, I know on your website, there's also a really great place on there that tells folks how to get involved with your research in case folks also want to do that too. So there will also be a video that folks can watch to learn more and get involved with you. So thank you so much for sharing all of that. And before we officially sign off, I want to let everyone know about a few additional upcoming events at the Seymour Center. So if you really loved this Labside chat with Adina, there are more programs just like this one coming up. So please mark your calendars for Sunday, January 17th. We have a Science Sunday lecture at 1:30 p.m. You can find more information on our website, seymourcenter.ucsc.edu, or click on the link in the video description below. Again, you can also mark your calendar for Tuesday, January 19th, where we have a members only behind the scenes event that explores our new California moray eel exhibit. So mark your calendars for that. Again, more information can be found on our website. And last but not least, Adina, I want to give you a huge thank you for being here today. Your research, your insight, and your expertise is always so inspiring. So thank you so much.
Thank you, Jen, and thank you for the Seymour Center for all the time that you guys put into communicating and educating and doing these wonderful programs for the general public.
Oh, that's very sweet of you. Thank you so much. And a big thank you to everyone that tuned in today and watched this Labside chat with us this morning. Really, these programs cannot exist without your support. So thank you so much for tuning in. And if you are in the position, I ask that you please consider either making a donation or becoming a member with the Seymour Center so we can continue these Labside chat programs and other educational programs well into the new year. So with that, again, I want to say thank you to everyone, and I wish you a great rest of your day, and we will see you very soon. Okay, bye everyone. Thank you.
Bye everyone, and stay safe.